I'm not going to have any slides. I don't think people would appreciate them. Um, but instead, I'll just try to do a very hands-on demo with the devices and with the operating systems and so forth. I'll start first about okay. So the presentation will be about this Halpai2 computer, like for 15 minutes. And then for another 15 minutes about this Halos operating system, which is a like browser first container app operating system for like based on Raspberry Pi OS. Yeah, but first, let me introduce myself. I am Matti Airas. I'm the founder and CEO of HATLabs, which is like a small Finnish company doing open marine electronics and software. I've been doing like HATLabs. Well, I founded HATLabs in the end of 2020, so I've been doing it a bit more than 5 years now. I have a PhD in electrical engineering, but for most of my career I've been doing software engineering in different companies and yeah, and the electrical engineering part is like now in HATLabs is more of a recent development. And yeah, I have a passion for combining sailing with open software and hardware geekery. This is basically how it all began. Like I began doing stuff for my own boat, and then it got a bit too serious, and I got too many ideas, and I decided that I would want to try to do it professionally. Um, yeah, so it's been partially that and partially consulting and so forth. But yeah, I am sailing an old Canadian CNC 36 sailboat. It's like from Helsinki, Finland, and yeah, it's the harbor was just today cleared of ice, but it's still usually the season starts in May around here, so I still have couple of more months to work on the projects before the season starts. Yeah. So let me first start with with the background. For the Halpai2, why I did that. So Raspberry Pi is quite popular in do-it-yourself marine projects, like people are doing like using it with OpenCPN and different types of do-it-yourself plotters and screens and basically all kinds of things. But the marine or the boat environment has its special features. So basically, you need to power the devices using a very noisy 12 or 24 volt power system, and there's all kinds of glitches and inductive spikes. So you like the starter motor might pull, or the windlass might pull the battery voltage down for quite a bit for a moment, and there are poor grounding of devices, so you have ground loops all over the place. Then you have heat and humidity. Like if you're sailing in the Mediterranean, the boat can easily be 40 degrees inside, and the devices should still survive. And you have like condensing environment. So the corrosion is always a problem with electronics there. And then if you have a regular Raspberry Pi, like you always need to worry about SD card or SSD corruption, like if you don't shut the device down properly. And then there's all like connection to marine networks, and which is always like NMEA 2000 and NMEA 0183 and so forth. It's always a bit of a problem. So one of the first things I did was this. This is a SHR RPI, like a sailor hat for Raspberry Pi. Can I zoom in? I think I was able to zoom in. Yeah, there. Um, so yeah, so this is basically a like a like a power supply hat for a Raspberry Pi, which takes in 9 to 32 volts and stores it in supercapacitors, and then feeds like 5 volts to the Raspberry Pi and any attached hats. And the idea is that the supercapacitors provide a short-term energy storage, like if you have any kinds of glitches or short blackouts or um, other power system issues, like this thing will help the Raspberry Pi ride them out. And it will also, when you turn off the electronics, let's say on the boat, it will well there's a service software, a daemon polling the microcontroller on this one, and it notices when the input voltage drops below a threshold, and it will then shut the OS down automatically. And yeah, um, um, it's a fairly specialized thing, but also has a lot of use cases. I then at some point the problem with that still is that it's kind of well, you still need to be assembling everything together, like it's just a hat, like it's not a ready-made system. So at some point I began doing these like pre-assembled computers. This is like the first thing, which is like a waterproof, like Halpai medium size, which is a waterproof plastic enclosure, and just a stack of fairly generic Raspberry Pi devices. Like there's a CM4 carrier board and a CM4 module over there, and this is the sailor hat for Raspberry Pi for the power supply, and this is a CAN interface board so that you can connect it to the boat NMEA 2000 system. But it turned out that these things it takes a lot of time, like to do this. I hope that like I could have done these in 30 minutes, like assemble them in 30 minutes, but it wasn't even close. Like it was like something like 75 minutes per device, and which like makes it didn't make much sense, and there were still maybe it wasn't the most professional setup in the world either. So yeah, um, like had to give up on those at some point. But then I figured out that like why not do a actual proper device that because that would have the same features, but it would be like a proper custom built device, and basically an evolution step of that. And then I came up with this HALPI2 basically. And yeah, so this is it's a like die cast aluminum enclosure, standard enclosure with a just like with custom drill pattern on the front face. Um, I have on this device I have this is a GPS hat that I can just like take off for a moment. Um, but yeah, so basically this is a waterproof um, Raspberry Pi CM5 computer, which has mm, like totally passive cooling, and like designed from the ground up for different types of like both marine and other like embedded use cases. So like for example, um, like house automation systems or industrial automation, automotive applications, in addition to the boat to the boat apps. I began this project in November 2024, and I think I'm still like it's at the moment I'm ramping up the volumes on production. So it's been a fairly long project. But yeah, let me walk you through the overall setup here. So I could just first take here's just the like only the PCB. And like that. This is it's a custom-made, custom design carrier board that's like designed by myself for just like for this project. It has a similar type of a power supply section here, like similar to the Sailor Hat for Raspberry Pi, but it has somewhat improved protection, and so this can survive voltage spikes of up to over 100 volts, and it's overall very sturdy and should be able to filter out all noise, like any noises, pretty well as well. It has a similar type of supercapacitor setup as the Sailor Hat for Raspberry Pi, but there's just 4 of them, and it's like it can basically power a CM5 module for 70 seconds or so. Like so, it can stay up sufficient time for even for like for a slow device to or busy device to shut down properly. The CM5 module is here on the bottom side, so here like it's not installed here, but it goes here. And the idea is that it's the CM5 module is in direct contact with the aluminum enclosure, and aluminum thermal conductivity is very good. So basically like the whole enclosure acts as a like big heatsink for the device, and the CPU temperature, or the CM5 module CPU temperature is typically only 8 to 25 degrees Celsius above the ambient temperature. So it's like a very efficient power heatsink for the device. There's also a like SSD slot here, and so you can have like you can use normal NVMe SSD cards. It has 4 USB 3s. Like this is a USB 3 hub which routes data to 3 of these ports. It supports 2 HDMI, like which are here, like these FFC connectors, and also like these camera and display DSI CSI connectors here as well, and gigabit Ethernet here. So basically all the normal Raspberry Pi interface is built in. And it's also it can also take normal GPIO hats. So like there's just a few pins are reserved for some of the interfaces, but typically any hat should work. But for the boat and industrial and building automation purposes, it also includes a fast CAN interface and an RS485 interface. And these can be on a boat. They can be used as an NMEA 2000 and NMEA 0183 interfaces, but CAN is very common in like in automotive systems. So like you could plug this into a car system to interface um, with the car buses. Or like RS-485 is very common in industrial automation and building automation and whatnot. So you can also use it for those purposes. Um, yep, and it also has um, Wi-Fi and Bluetooth via an external antenna. So maybe I could bring this back here. It's looks a bit busier, but let me put this back in place over there. Yeah. So here is the okay. No, sorry. This is the GPS hat antenna, but here's like the Wi-Fi antenna. You have to have an external antenna because it's a metal enclosure. So yeah, it wouldn't radio waves wouldn't penetrate it that well. But the enclosure itself has this is a power connector, NMEA 2000 connector. It can also be powered by the NMEA 2000 bus if you just switch the power plug inside the enclosure. Okay. And then you have Ethernet, HDMI, and two USB 3s. So two are only available inside the enclosure, but you can use it with different dongles or whatnot. And also you have three blind plugs for like adding custom connectors if your use case requires them. Yep, that's pretty much the hardware tour. I could then boot it up. Here's the power. When I connect the power, it's in a moment it starts. So here now it's like you have the a red LED and it starts like this basically indication like charge indication for the supercapacitors. And at 6 volts or so, now it turned yellow. It'll start booting the device. So you have the internal LEDs blinking all over the place. And let me just finish connecting the interfaces. This is always a bit difficult like that. And I'm still missing something. Yeah, the HDMI, which is not that important, but let's put it in like that. Yeah. Yeah. Now, the LEDs have turned green. So there is a microcontroller on the carrier board here. It's actually an RP 2040, so it's the same as at the Raspberry Pi Pico, and it controls the supercapacitor charging and different peripherals on the board, and it also communicates with the host OS or the Raspberry Pi OS over I2C. So you get all the input voltage values, you get the input currents, like you get the charge voltages, and you can also do things like control the power of the USB devices. So if you have this thing in a remote location which is not easily accessible, then you can, and you have a USB device that's stuck, that needs rebooting, you can do that remotely by power cycling an individual port if you need. But also, yeah, the microcontroller also controls the LEDs and things like that. So it's fairly busy thing there. Um, yeah. Um, I guess this is more like a basic tour of the Halpai 2. Um, I could then move on to Halos, which is an operating system project that I also have. But Richard, what do you think? Like, should we take questions now or at the end?
I think at the end is great. Yep,
Okay, yeah.
you're fine, thanks.
Yeah. So, yeah. Then the background for the operating system part is that, like, yeah, of course, like this thing needs an operating system. Um, I was it was the audience was mostly like both people, and there's a uh, established project called OpenPlotter, which is basically a customized Raspberry Pi OS um, that includes a lot of marine specialized applications like chart plotters and the signal case server and so forth. But unfortunately, that project has become somewhat stagnant. It's still they still haven't released, for example, a new OS version for the Raspberry Pi OS Trixie, and also their development model was a bit difficult to uh, like participating in that or making the custom slightly customized version for the which would have the um, basically this thing pre-configured, like it was more hassle than I was happy with. And then at some point I decided that something needs to be done, and in the Signal K community we had a lot of talk about that, like there should be actually a like distribution or that for Raspberry Pi OS distribution that has containers as like Docker containers as first class citizens, and um, and also in my opinion and in some other people had the same thoughts that also like the world is moving like from the desktop paradigm to more like of web-based applications, and they're also very natural fit for both environments because you can use then different devices as terminals for the centralized computer. Um, so yeah, so basically then the requirements were from these two three yeah, so support headless use cases like you should be able to access the device with a web browser, preferably without having to use SSH or terminal access to for configuration, because then that limits the audience quite a bit. Yeah, containers are very nice and natural fit for these web app deployment and updates, and it's like keeps the different apps like very nicely isolated, so you never have any issues with Python versions or Node.js versions or whatever, because it comes as part of the app. And one another requirement was that the OS or the distribution should use the standard OS tooling, like it's um, like apt is there and Debian packaging is there for application like app distribution, and it works great, and there's like no real need for reinventing the wheel and so on. So and based on those, I then started building the house project. And yep, I will then give you a live demo. I need to share the screen there. There. Share. So, okay, I have here the screen running like browser screen, which is logged into the halasdev.local, which is the device running on the different camera. And so this is a dashboard for the thing. Like the idea is that everything should be also like basic applications should be usable with a touchscreen, and like because if you're in a sailboat cockpit, like you're not going to have a keyboard or mouse there. And this is a Homar. This Homar, which is a fairly regular dashboard for home servers and different types of applications, but what I just like reused it for this purpose. There is Cockpit is it's a Red Hat project actually. It's a web-based UI for computer management. Come on, load. Yeah, okay. And I basically it actually is available on the Raspberry Pi OS repositories and the Debian repositories. I added some modules here, so like there's a okay, networking has what is it so slow? Networking. Okay, yeah. So the networking module didn't have, it was more geared for server use, so it didn't have any support for Wi-Fi or so forth. So, but now it's possible to configure your Wi-Fi networks with directly from Cockpit. But I just reflashed the device, so there's a pre-enabled access point which I'll just disable because it's not a good idea to have it on. And yeah, I could connect to different networks here and if I wanted. But then there is a okay, so there's like standard this is a like standard app interface like which for Debian packages. But then also I have this container app concept, which is basically Debian packages with a specific tag. So it just searches the repo for a tag in the package, and then if it's there, then it's determined that it's a container app. So I can use and the container apps are well, they are Docker. Yeah, they are based on Docker, but the app itself is just a bit of metadata and a Docker Compose file. So when I install, let me install AvNav, for example, which is a chart plotter app, like a browser-based app. I can install it, and the actual Debian package installation is pretty fast, but then it starts like once that is installed, it starts pulling the Docker containers, which depending on your like internet connection bandwidth might take a bit of time or not. But it's now it's started, yeah. And any app that is installed, these container apps, they have metadata that then populates. If I go here and reload the dashboard, it pre-populates the dashboard. So this AvNav application is available here. I can click on it. Oh yeah, okay. Now there's a single sign-on for all of these apps. So I just need to put admin and Halas is the default password, and now I'm signed into all of those apps like in the system. Let me just okay, and here this is a basic but totally completely usable chart plotter already here. This is the Helsinki harbor. Okay, yeah, and this would be where our boat normally is, but yeah, so you can very easily install these different Docker based applications, and there's the selection isn't huge yet, but I am adding stuff there as time goes by. Let me next show you Signal K, which is one of the more central or core applications in typical boat setups. Signal K is a data server or data hub for boats, so it can receive data from the NMEA 2000 or over Wi-Fi or from like other custom devices or Bluetooth, and it can then display it with different like dashboard interfaces or sorry, or there's a data browser. So this is all the data at the moment in the network. So most of these entries just come from the carrier board of the device. But yeah, something like GPS information and so forth are available here as well. And the plugin selection is really huge. There's like literally hundreds of plugins for all kinds of different use cases available. Also, chart plotters and things like that. Let's go if what's available like. Yeah, okay. It's just the open CMap, so nothing really interesting available here. But yeah, those are like usable out of the box almost. And there are also charts available for them. Yeah, so all of this has been heavily like implemented heavily using Claude Code. I have a workspace set up where I can like explore and plan and implement different features and like a GitHub continuous integration setup where it then like can releases the different Debian packages in a controlled fashion and builds them in like then builds operating system images. So yeah, Halos is it has images for the Halpai2, but it's also available for also like there's also non-marine versions. So like if you're just interested in the container app concept and in the browser first user experience, you can use it without the marine stuff, and you can also use it with a like plain old Raspberry Pi without it doesn't need to be the Halpai2. So it's actually like in that sense, in that regard, it's a proper open source project which I'm trying to like portray it more as a generic distribution than just something that for these devices, because I would very much like to attract more users and more developers for that. Yeah, I think I've pretty much used my time at this point, but I would be very happy to, yeah, share, like ask, like if you have any questions, answer them and or demo any particular thing.
Yeah, thanks very much. That's really interesting. Sorry, could drink water. Did you hear that question?
Sorry, no.
Who manufactures your PCBs?
Could you repeat?
Just give me a second.
Who manufactures your PCBs, your circuit boards?
I didn't get the beginning, like something about the circuit boards, but can you, Richard, maybe repeat it like closer to the microphone?
Who manufactures your circuit boards?
Okay. Who manufactures? Yeah. So at the moment they are all done in JLC PCB. So far, I haven't had need to go for customized like fab houses. Like I'm fairly happy with the setup I have, like for automating the workflow and for the PCB orders, and yeah, the latest batch is about 200 circuit carrier boards. But at some point, like it might be that I need to, it would make sense um, to start working with a more specialized like fab house. But so far, JLC PCB has been fine for me.
Yeah, I use them as well. I find them pretty good. And,
Yeah.
and you KiCad or something, or what is the software you use for designing it?
KiCad.
KiCad. Okay.
Yeah, it's everything is this is open hardware. So yeah, so it's here. Everything is available on GitHub. This is okay. Yeah, README is fairly poor, but this is this is the whole fairly up to date. Oh no, it's not up to date at all. It's like I haven't been pushing. I haven't been pushing lately, clearly, but I'll do that.
Yeah, I find KiCad really good, even creating custom footprints, etc.
Yeah, I'm happy with it. Like I have no reason to use anything.
JLC PCB is cheap, and it's between 7 and 10 days from the upload to it being on your door. So it's very good.
Yeah, it's not perfect. Like it's but like yeah, like you have to fit your design process to their system, but and not not vice versa. But yeah, it's worked fine for me. Like and yeah, it's I don't have much to complain.
Do you assemble them yourself then? You like put the components on and solder them in, or?
No, so well, um, so the PCB assembly is done by them as well. Like so, I get almost ready-made PCBs from them. I add the supercapacitors, and then I have a test jig. Well, I could actually. It's very messy, but there's the orange thing in there over in that direction. It's a PCB test jig for production testing. So every device is fully tested in the test jig, which tests like the power supply and the CAN and RS485 interfaces. What else? Yeah, it flashes the microcontroller and so forth. And then there's a second stage for the fast interfaces, like for the SSD, for HDMI, for USB 3, and that's also when the like when the operating system is flashed on the devices. So basically 2 stages of production testing for every single device.
So how many have you sold then?
A bit more than 100 only because yeah. So far, I began sales in July last year, and then there were still all kinds of smaller teething problems um, uh, throughout the fall. So the order quantities were quite small. I'm now trying to ramp up the quantities, but there's all kinds of interesting issues with, for example, connector suppliers and different Chinese suppliers, which like it's a learning experience how to work with the supply chains.
Right. And getting your CE mark, what's involved in that? Is that difficult or is it?
Um, it's
Quite
so
expensive?
it's the cost. Cost depends on where you do it. Like it's like if you in most Western European countries, it would be several thousand euros doing the um, like yeah the EMC testing but in China you can like Shenzhen area is full of testing labs that can do it for 1,000 to 2,000 euros, and like they will produce the documentation for you. Um, for many of my devices, especially the older ones, I've also just like I have a well because with my electrical engineering background, like I'm like kind of understand the process, and I've then also like just done like self certification, which is technically not what you should be doing unless you can completely replicate the process. But then because these are low voltage devices, they are all like 12 to 24 volts. They are not mains powered, and you can't. There's no risk to human health or like there's no risk of injury like with using these. So been basically doing the conducted noise measurements, like radiated noise measurements, conducted and radiated immunity measurements, and having a fairly good confidence that these things would pass like a proper lab testing. So that's basically, yeah, many small houses like just need to do it like that because it's like it gets expensive otherwise.
Yeah. And the HAL OS, when you get a new user that's not like a computer guy, computer person, how do they take to it? Is it quite easy for them? Do you have a lot of questions coming back?
Well, so it's a new project, so it's like of course like the basic uh, experience, the basic startup flow is pretty okay. Like it's like you log in with a browser, you go and you can set up the Wi-Fi and you can start using it. But then again, it's still buggy. So it's of course there's still things that I need to tweak still, and it's like by myself I'm not able to to test or even anticipate all the use cases people have. So it's like uh, it's getting there.
Yeah. And do you have other contributors at this point, or are you still?
Not really at the moment. Like I would very much want to have more.
Yeah. And how's the open source hardware treating you? Are you enjoying that, or is that a lot of trouble, or is it just?
No, it's not trouble at all. Like it's well there are so yeah, so many of my previous things have been these these types of ESP32 development boards that I still sell, but there's like and they're like also have enclosures, like waterproof enclosures, so you can do both hardware with them, custom hardware, and like different sensors and engine sensing or NMEA 0183 interfaces and different types of things that you could do with an ESP32. But they are simple, like more like simpler devices, and the KiCad schematics and everything is like the design files are also available for them. So that's like some people have used those for their own projects. So like maybe if I would have been more protective, then maybe that would have like been a consulting thing for me. But then again, maybe they wouldn't have used those in the first place. I don't think I have lost any significant amount of sales for doing open hardware. It's like I think it's especially like for example this HALPI2. Like I'm kind of happy if people can um, take some bits of the design and reuse those in their own circuit boards. But the whole thing with the testing and with the enclosure and with the sourcing of components and whatnot, it gets kind of complicated. So it's like as long as it's not attractive for Chinese manufacturers to take and copy, then I think I'm good.
Yeah, that
And
makes a lot of sense, really.
yeah, yeah, it's like kind of just like fits my background of what I've been doing. Like I've been very pro open source, like throughout my adulthood, basically. So it's just fits. It's a natural fit for me, I would say, to do it like this. And it's also like a differentiator for me, like for my business bit, like I'm not Ray Marine or I'm not BNG. Like I'm not trying to do those walled garden boat hardware systems, but I'm trying to basically break down their walls that they are building, like to basically being able to interface different types of devices more easily and um, yeah, it's a good fit for me.
And the compute module, your use of the compute module, how are you finding that? I've never used one, so I'm just wondering, is it just a drop in for the Pi, or is it complicated to get started with those, or how does that actually go?
Um, well, I don't. Well, okay. So software-wise, it's like 100% compatible with the corresponding Raspberry Pi. So it's like it has the same exact SOM system on module, and it has the same exact interfaces and everything. So and performance is also like just like exactly the same because all of that. Um, it's there are some complications to using it. Like some like if you're using those like okay, some of those CM5 modules come with eMMC like built-in eMMC memory, so you don't have to use SD cards, but like there's a 8 to 64 gigabytes of built-in memory, which is somewhat faster and more reliable than the SD cards. Most of my devices have like a separate SSD card, like so basically a hard drive, like 512 gigabytes or 1 terabyte hard drive. So they don't use that eMMC, and uh, then it's just like yeah, very very similar to a regular Raspberry Pi, but it's like yeah, there are some minor differences where like how you can flash it in more than one way and uh, things like that, but it's pretty much the same.
I guess you could drop in a Pi 4 and you would just lose a bit of performance. Is that right?
So this is so yeah the HALPI2 does work actually with the CM4 module as well. Then some of the interfaces, some of the USB, I think, yeah, some of the USB ports work only as USB 2, and there are some limitations what it can do then. But the CM4 and CM5 modules are exactly like have the exact same price. So it doesn't really make like if you're buying new items or new stock, then it doesn't make any sense to use it as like with the CM4 as opposed to CM5. So, but they are somewhat backwards compatible. Yeah.
Yeah. And in your test rig, you talked about your test rig. Do you just like after you assemble the case and everything like that, I guess you retest everything again, do you?
So yeah, okay. First, like the whole previously I was doing the assembly of the this I know this wasn't what you were asking, but I'm explaining nevertheless. So the for the first batches, I was doing the assembly of the enclosure and the connectors myself here, but it's like that that's that takes a lot of time, just attaching all the connectors and organizing everything. It's um, maybe 15 to 20 minutes per enclosure, so it's fair amount of time. And now I'm having all of that done now in China. So I like have some suppliers there where I like with which I have a very good collaboration, and they are basically assembling the enclosure. So I get them with all the um, all the connectors and everything enclosed, like all pre-assembled. So then it's just the carrier board, the PCB that goes in the orange jig, and then and that is a fair automated process. It takes 3 to 4 minutes per board, but it's like I just don't have to sit there. I can prepare the next one or whatnot, and then assembling the thing with the like the whole enclosure with the pre-assembled connectors is that's quite fast. Like that's just a few minutes of time to slap on the CM5 module, add the thermal pads, and put on the connector, connect the connectors, and yeah, that's fairly fast.
Right. And does this also operate as a black box? Like, do you record all the nautical data that you receive?
Yeah.
So you know where your boat
Yeah,
was.
you can do that with a single K. Yeah.
Right.
And there's yeah, the screen sharing is still on. So there is
Right. It's all in the apps, I guess. And
yeah, there's also like come on. There is Grafana and InfluxDB here available, so you can also do Grafana plots of historical data and like that you can store with InfluxDB. And yeah, so I like I'm a data nerd myself, so I have like of course like complete recordings of the the boat, not just the navigation data, but basically all data on the boat. And it's kind of also nice for a remote um, like remote admin system, like you can or like remote um, what do you call it? Like remote, not it's not remote control, but like you can just check the battery levels and the and everything on the boat that it's like it's still floating.
right. And where are your users right now? Do you have people using your kit all over the world, or are they mostly
All over the world. So 45% in the EU, 40% no, 40% in the EU, 10% in more in non-EU European countries, um, 35 to 40% in the United States and in the North America in general, and which is a pain at the moment with the customs, and then a fair amount in Australia and New Zealand. At the moment I'm selling everything from Finland, but it's like the shipping costs are huge. So I am now that once I get the a bit more stock, like bit larger amounts, I'm then definitely trying to get resellers in some of those main markets.
Oh. So do you find it difficult to export the stuff, or is it fairly easy to export from Finland? I mean, other than the price.
Exporting is in itself is not difficult. Like it's it's some fair amount of tweaking to get all the tariff codes and whatnot in place, like in the e-commerce. Like I'm using Shopify as the store platform, but then once you have that and you have the logistics providers, like they have normally their own apps that integrate with Shopify, and then you can, like, if it's in the EU, it's easy. There is no paperwork required. If it goes to the UK or to Norway or Switzerland or elsewhere, then you need to have a export form, and then the customer.
The dumpy trucky tariffs keep changing all the time, so that must be really hard.
Pardon?
The dumpy trumpy tariffs change all the time.
It's crazy. It's absolutely crazy. Like it's like so I was mostly shipping with shipping the items with postal parcels. You don't do that to the US anymore. They changed the customs requirements so that like no postal service parcels are from anywhere in the world can, like, I can't say anywhere, but from the EU countries, it's not possible to ship them to the US anymore. It's really difficult. Like I can do UPS, but it's really expensive, and there's no like these de minimis limits anymore. So previously you were able to import orders of up to $750 or something like that, tax free, which made it fairly easy for the US customers. Now they have to clear it through the customs, and UPS is doing a horrible job with that. Like they're doing, like, it's all the time having like customers are complaining that they're paying extra like customs fees, clearing fees, even though they shouldn't, and it's painful.
Yeah, that's too bad. It's crazy.
Yeah, it's like, it's something that I really need to get like amazing presence in the US as soon as possible, to basically, so I would be importing the items myself to the country, and then there would be a bit of extra price, but then the customers wouldn't have to deal with the pain.
Excellent.